Hello boys and girls. Today what we're going to discuss is section 1.3, rational and irrational numbers. So we're going to go through a couple things here, and let me just describe the four topics we're going to go through. First, we're going to talk about definitions. Then we're going to talk about perfect squares. I'll explain what that means. And square roots, they go together. And then we're going to talk about classifying numbers. And classifying numbers means we're going to give things names. So we're going to call them by a couple different new names here, okay? So, first thing, let's talk about rational and irrational numbers. So I have here the two titles, rational and irrational numbers. And what we'll do here is we want to look at kind of where these numbers belong. So rational and irrational numbers both belong to a set of numbers called real numbers. And that sounds really weird, but we look at real numbers. Real numbers are all the numbers we deal with. And we take that set of real numbers and we can divide it into rational versus irrational numbers. That's the first category. And if you ask if it's not real, what is it? There actually is a whole set of numbers called imaginary numbers, which we'll get into later on. You don't need to use them for this course, but you will use them for Algebra 2. Okay, so let's talk about rational and irrational numbers right now. So rational numbers are anything that can be written as a ratio. Okay, that means a fraction. Okay, it can be a decimal, and we'll talk about how decimal can be written as a ratio. It's anything that can be written as a fraction. That's what rational is. Now, irrational, actually the definition is just that you cannot write it as a fraction. Okay, so you can't write as a fraction anything that's irrational. So those are basically the two characteristics. So if I say to you, what about the number 3/4? Where would that go? Well, 3/4 is a ratio that goes here. And if I say to you, what about 1.4? 1.4, that goes here. How about 0.3 repeating? Actually, 0.3 repeating is a rational number because, you should know this is one of the common benchmarks, 0.3 repeating is actually 1/3. So since I can write it as a fraction, it's a rational number. Now let's go through a couple other pieces of vocabulary here that we're going to be using. First one is simplify. You'll hear me say simplify often, almost every lesson. Simplify means reduce. It means to make it more simple. It follows everything you learned in 5th grade, simplifying fractions. I'll reference 5th grade a lot because reducing fractions is key in this class. Evaluate means give me an answer, okay? So if I say evaluate this expression or evaluate this number, you're going to give me an answer. That's what that means. And substitute means to replace a number. So if you need to substitute something, you're going to be replacing a variable with some number, and you're going to figure out what that should be. I will also tell you that substitute is my favorite word. I'll use that a lot, and I'll tell you, I'll ask you what to do, and if you don't remember what to do, I'll say what's my favorite word, because we use substitution a lot. Substitution helps us out a lot in algebra, okay? So we're going to look through some of these key things here. So the first thing we're going to look at are what I call perfect squares. And perfect squares are a number multiplied by itself. So 1 squared, 1 times 1 would be 1. 2 squared is 2 times 2, right? 2 times 2, which is 4. 3 squared is 3 times 3, which is 9. And 4 squared is 4 times 4, which is 16. So these are my perfect squares. So 16 is a perfect square because it is 4 times 4. So you are going to learn your perfect squares. We're going to practice in a minute, but you're going to learn your perfect squares. You're going to memorize them up through 25 squared, and you will use them throughout the entire course. From this first day all the way up to the last day, you'll use perfect squares. Now, we want to go in reverse. Reverse is a square root. So now we're going to take square roots here. This symbol right here is called a radical sign. It means a square root. And we're reversing perfect squares. So the square root of 1, well, 1 is 1 times 1, right? That's my perfect square. So the square root of 1 would be just 1. The square root of 4, remember up here we said, hey, 2 times 2 is 4, so the square root of 4 would be 2. And the square root of 9, well, we remember 9 is 3 times 3. Square root of 9 is 3. And the square root of 16 is, well, 16 is 4 times 4, so the square root of 16 is 4. Now, when you get into integers, we're going to remember that actually 2 times 2 is 4, but also negative 2 times negative 2 is also, negative times negative is a positive 4. So really the square root of 4 is 2 or negative 2. And we're going to use some of the negatives later on, but right now we're just going to focus on the positive version of our square roots. Okay? So now, we are going to do a little practice. And what I have here is, if you want to write this in your notebook, I want you to make, if you can pause the video here, I want you to make a little grid here, 1 squared, 2 squared, 3 squared, all the way up to 10 squared. On the next row, you notice I took my notebook paper and turned it sideways so I can get it all in. 11 squared to 20 squared. And then I went from 21 to 25 squared. Now, I do have this, if you printed it off my website, I do have this that's kind of pre-printed. You're welcome to print this off the website and use this. We will use this a number of times. But if you want today, we can just use the handmade copy, and that's totally fine. So you're going to print this, you're going to make this. You can pause the video as you make it, and then we're going to fill in. So as soon as you make it, you're going to fill in as many as you can. Okay? So you can pause the video for a minute, fill those in. Okay, so now let's take a look at what we have here. So we're going to fill in as many as we can here. And what we're going to do is just fill in the answer, okay? So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, then I have 25, and 36 for 6 squared, 49 for 7 squared, 64, 81, 100. You should not have any trouble with those first 10. Okay, the second row gets a little bit more challenging. So now 11 squared, you should know that's 121. 12 squared, 144. 13 squared, you might remember that, that's 169. Okay, and now we get into the ones that are tougher to know, and this is where you're going to have to start to memorize these. 14 squared is 196. 15 squared is 225. 16 squared is 256. Then we have 289, 324, 361, 400, okay? And then the last row, half a row here, we're going to do 21 squared is 441, 484, 529, 576, 625. Now, there's a couple things I want you to notice about this. This chart, first of all, you're going to need to keep on hand as we do the homework for Chapter 1. As I said, you're going to have to memorize all these numbers, so that's fine. You'll be able to do that. But I want you to notice some patterns here. And the reason I set it up as 1 squared through 10 squared, 11 squared through 20 squared, and I only did half of this row not to make it too tough here. But you can see that we're all lined up. Okay, 1 squared, 11 squared, 21 squared. They all end in 1s. Okay, now look at my answers. 1, 1, 1. Okay, 2 squared. Well, 2 squared I can remember is 4. Well, 12 squared is 144, ends in 4. 22 squared is 484, ends in 4 again. 3 squared is 9. 13 squared is 169. There's the 9 again. 23 squared is 529. If you notice, each column ends in the same number. So what you can do is it helps to memorize this by when you set up the first row of the ones that are easy to remember, when you set up the second row, it's going to help you. So if you remember 225, you're going to think 225, oh yeah, that goes in that 5 column. That's 15 squared, okay? 625 is a perfect square. That is 25 squared, okay? So you are going to both memorize this the way we just did it and also recognize these perfect squares. So if I tell you, is the number 289 a perfect square? You're going to say, yep, that is a perfect square. It is 17 squared, okay? So we want to memorize this. This is going to be really important. So you can work on that a little bit every day to practice, okay? And again, you can just set up this in your notebook. If you want to time yourself, give yourself 2 minutes to try it, see where you get them right or wrong, okay? And again, if you want to print them out, you can use this sheet. This is on our website. Now, we're going to practice things a little different here. So we're going to take a look and just see if we can recognize some of these numbers. So the square root of 81 you should recognize is 9. The square root of 36 you should recognize is 6, okay? No problem. You could have done that over the summer. That's easy. So now I have this thing, square root of 81 over 36. So I do not want you to plug that into a calculator. What you're going to do is say, well, I actually can split this up. Square root of 81 over the square root of 36. Now I should recognize that the square root of 81 is 9 and the square root of 36 is 6. Okay, did I set that up right? And now, again, I'm going to say, remember you graduated out of 5th grade. So what we're supposed to do here is reduce this. So let's divide the top and the bottom by 3, and I get 3 over 2. And I can say, well, I can say 1.5 if I want, or 1 1/2 as a mixed number. Okay, now let's look at this one. Square root of 49. Again, I know that one. That's 7. Square root of 49 is 7. What about this one? Square root of 0.49. Okay, now I got to remember those decimal rules again. Well, first of all, the square root of 49 is 7. But when I multiply 7, if I have a decimal in there, let's take a look at what I can do. If I have 0.7 times 0.7, 7 times 7 is 49, and I count up my decimal places, 1, 2, that gives me 0.49. So you're going to have to play a little bit and remember your decimal rules when you have to take the square root of a decimal, okay? So that's some easy practice to do. Now, in addition to that, and this is where you want to have your perfect square chart with you that we just did, you're going to have to estimate things that are not perfect squares, okay? So if I want to estimate things that are not perfect squares, I'm going to say, well, this is estimate, okay? I'm going to think of what's closest. What's my perfect square that's closest to this? So I'm going to make a little number line, okay? And the closest perfect square to this would be the square root of 16. The square root of 16 is 4, okay? The next perfect square, that's the next perfect square, would be the square root of 25, which is 5. And 17 is just a little bit more. So I would say the square root of 17 is a little bit more than 4. I can guess and say, well, let's guess it's 4.1, okay, because it's a little bit more than 4. You could, if you estimated 4.2, that's totally fine. Anything along those lines on the lower level of 4. Now, if the question says, hey, estimate it to the closest whole number, you're going to say, well, it's closest to 4. So let's do another one. Square root of 34. So let's think, what numbers are perfect squares around it? Well, I know that square root of 36 is 6. That's a little bit bigger. And then the next one down would be the square root of 25. That's 5. So this is just a little bit smaller. So I would put it like maybe right here, square root of 34. And I could say, well, maybe that's 5.7, 5.8, something like that. And again, if I say which whole number is it closest to, you're going to say, well, it's really 34 is close to 36, so it's closest to 6. Okay, so you're going to have to estimate with these squares and square roots. Okay, now let's go back to rational and irrational numbers. What we're going to do now is classify. So I have a couple extra names to call these numbers, okay? So we had first, our main category is real numbers, and then I have the category rational and irrational. So remember, rational is anything that can be written as a fraction, okay? And irrational is, I'm going to say, not a fraction. Okay, so that's kind of the easiest way to remember it, not a fraction and fraction. But let's look at irrational numbers here. If I look at what we just did with my number line here, I have these numbers in between, square root of 34, square root of 17, okay? I have those things, and if I look at those, if you were to do that on your calculator, and if you have a calculator, you could try it right now, the square root of 34, you get a number that fills up the entire screen. It never repeats and it never ends. And that is the definition of an irrational number. Never repeats, never ends. Okay? Now another way to say that is it's the square root of a non-perfect, square. So in this example here, square root of 36 is a rational number because 6 can be written as 6 over 1. Square root of 25 is a rational number, that's 5. Square root of 34 is in between those. So I estimated at 5.7, but it basically goes on, so that is a irrational number. So irrational numbers, not a fraction, never repeat, never ends, and the square root of anything that's not a perfect square. So let's look at some names for rational. We don't use these names too often. Sometimes we'll talk about them, but the term natural number is anything that starts with, that means a set here, starts with 1, 2, 3, and it keeps going forever. Those little squiggly things mean a set. Whole numbers are the same type of numbers except they start at 0. Okay? And integer numbers are whole numbers plus the opposite. Now, if you notice here, whole numbers, integers, whole numbers and their opposites, they're like the whole numbers. I can say 1 or -1, okay? I'm not using fractions here, even though they're rational numbers. Any whole number, so let's say the number 7 can be written as 7 over 1, so we still call that a rational number. But in this case, we're looking at natural, whole, and integers are numbers that don't have any fractions or decimals to them, okay? So let's take a look at a couple examples here. So I made a little number line here. You can make a number line, and I went 1 through, I extended it to 9 there, okay? So I'm going to give you some numbers to put on here. So let's start easy. Square root of 4. So let me just write up here, or down here, let's see. Square root of 4 is 2. So where that goes on my number line is right at the 2. Now, is it rational or irrational? Well, rational, 2 is a rational number, so I'm going to put square root of 4 is right there. Let's try square root of 9. Well, we know the square root of 9 is 3, so on my number line here, square root of 9 is 3, so I'm going to put square root of 9 right here, okay? And let's try a different type of number now. Let's try the square root of 3. The square root of 3. Well, the square root of 3, that's going to be a little tougher. I can't really figure out where that one is. Square root of 3 is, let's see here. Well, it's less than 4, so it's going to be somewhere here. So that is an irrational number. Okay, it's not, it doesn't fall into the whole numbers, the perfect squares that are rational. Let's try another one. Let's try the square root of 8. Okay, square root of 8. Well, square root of 8 is almost the square root of 9, which is 3. So it's going to be a little less than that, so it's going to be right here. Now, when you start doing this and trying to figure out rational and irrational numbers, again, you should recognize your perfect squares. Okay, so that's the rationals. And the irrational numbers, if you're not sure, you can put on your calculator square root of 8, and it's going to give you 2 point something, and you're going to be like, oh yeah, okay, so it is between 2 and 3. So in the beginning, if you need to use the calculator for the irrational numbers, that's okay. But you do want to start to recognize them. And the more you memorize those perfect squares, you're going to recognize if it's not a perfect square, then it is not a rational number, okay? So I think that's good for us to stop at today. I want you to take out the homework page. It says section 1.3 on it, and you're going to try those practice problems now, okay? All right, let's give that a try.